Hi everyone, in the previous lectures we have discussed that one of the purpose of this module is to calculate the internal forces of a beam at a specific location. And let's start with a simple example, okay, which is example 1 in here. We have a simply supported beam, okay, so it is pin supported at A and then roller supported at B, okay, and the point loads X on the beam at the midspan P, okay, and then another point loads X on the beam horizontally at B, which and has a magnitude of P over 4, okay, and in here we have to find what is the axial, shear, and moment internal force, okay, at X equal to L over 3, where X is measured from left to the right start from point A, okay, so X is measured from left to the right starting from point A. Alright, so before we continue calculating the internal forces, it is always a good idea to first calculate the reaction forces of the beam, okay, and in here in this case we have AY and AX, right, since a pin support, and in here we have BY. Alright, and I will let you do this on your own. I will just write down the answer over here that AY should be P over 2 and BY should be P over 2 and AX over here is negative P over 4, okay, and I hope that you have time to do this on your own and then double check your result with this result, and if you obtain different result then please let me know, okay. So to calculate the internal forces at X equal to L over 3, I have to make a cut right at X equal to L over 3, which is the point right here, okay. When I make that cut, I will separate the beam into the left hand free body diagram and then the right hand free body diagrams. So in here I'm going to sketch the left hand free body diagrams and the right hand free body diagrams. So this is the left hand free body diagrams, right, and then this is the right hand free body diagrams, right, and then we have load P applied right there. It exists in the right hand free body diagrams, right, and then we have load P over force at point B, okay, right. Then don't forget we have to include the reaction force BY. In here is P over 2, right, and then same thing in here we have AY is P over 2, and then we have AX is minus P over 4, okay, okay, this is AY, this is BY. Alright, and we have include all of the applied forces, we have include all of the reaction forces, then I think this free body diagram is complete now, okay. So, oh, wait a minute, it's not complete yet because there's one thing that we're missing, right, which is the internal forces. Remember when we make a cut we see the forces, so we make a cut at X equal to L over 3, right, this length of the beam right here is L over 3, this make that this length over here is 2L over 3, okay, and then the distance right here is L over 6, okay, L over 6, okay. So once we make the cut we see the force, so at X equal to L over 3 we will see a moment in here, and let's label it. Let's label this point as point C, okay. Then this is point C, this is point C as well. So in here we will have MC, right, and then VC, okay, and then NC, okay. Notice that all of the directions that I draw for these internal forces are in positive sign conventions. Okay, if you go back to our previous lectures, they are all in the positive sign conventions as shown in here. Okay, then we can draw the on the right hand free body diagrams. This is MC, this is VC, and this is NC. Okay, and then all of the forces that I draw in here, right, the internal forces that I draw in here are all in the positive sign conventions as what we have learned in the previous lectures right here. Okay, okay, so in here we have a left hand free body diagram, and then we have a right hand free body diagrams. Okay, so when you solve this problem, you can choose either the left hand free body diagrams or the right hand free body diagrams. Depends on which diagram that you think is easier. Okay, so but for this lecture I'm going to show you the solutions using these two free body diagrams, and the result has to be the same in terms of the magnitude and the sign. Okay, if it's not the same, then something is wrong. Okay, so let's do let's start with the left hand free body diagram first. When I take sum of the moment at C, okay, which is this point right here, right, I have MC. It has positive sign, right, because it's counterclockwise. Okay, and then I have negative AY, right, divided by negative AY times L over 3, which is the distance to C. Okay, and then set this equal to 0. I will obtain that my MC is equals to AY times L over 3. My AY is P over 2 times L over 3 is PL over 6. Okay, and then we can continue with doing the sum of the forces in the Y. Okay, so when I write sum of the forces in the Y directions, I have AY minus VC equals to 0. So my AY in here is equal to VC, right? In other words, my VC is equals to AY is equal to P over 2. Okay, and lastly, when we do sum of forces in the X, we have the contribution of NC and AX, right? So sum of the forces in the X, we have NC plus AX equal to 0. So my NC is equal to negative AX, and AX is negative P over 4. So this is equal to P over 4. Alright, so this is the result that we obtained from the left hand free body diagrams. So keep in mind that in the right hand free body diagrams, we should obtain the same result in terms of the magnitude and the sign. Okay, and this is, we can call this as a finalized step, right? Finalized step where we try to reason out whether the result that we obtain in here is makes sense or not. Okay, so on the right hand free body diagrams, okay, we can start by writing sum of the moment at C. Okay, sum of the moment at C, that when I write sum of moment at C, I have in here is negative MC, right? Negative because MC is going clockwise, right? And then I have contribution from this P force right there. So negative P times L over 6. Negative because it's also counterclockwise rotations with respect to point C. And then lastly we have this BY, right? And BY right now is positive because is going counterclockwise, right? Okay, and please keep in mind that in here when we write these equations, right, the positive and negative sign that we include in here is based on whether the moment that we produce from that force is clockwise or counterclockwise. Okay, so it's different with the sign convention that we discussed in the previous lecture for the internal forces. Okay, please make sure you differentiate those two sign conventions that we have learned. Okay, and then writing this, we have MC. Okay, move MC to the right hand side equations. We have By, right, times 2L over 3 minus P times L over 6. So By is P over 2 times 2L over 3 minus PL over 6. PL over 3 minus PL over 6 is PL over 6. And if we check the result in here, oh yeah, they are the same. Okay, so we are happy, right? And we continue with calculating VC, the shear at C, right? By doing sum of the forces in the y directions, we can write VC positive because it's going up, and then negative P going down, right? We have negative, and then positive By equal to, because By is going up, so VC is P minus By. Then we have P minus P over 2. You have P over 2 right here. And we check again with the left hand free body diagrams. Oh, it's the same. So this makes us even happier. Okay. And lastly, let's check for the last internal force, which is the axial force. And we do some of the forces in the X. In here we have negative NC, negative because NC is going to the left, and then we have positive P over 4, positive because P over 4 is going to the right, set it equal to 0, and C is equal to P over 4, right? And we check the result. They are the same in terms of the magnitude and in terms of the sign. Okay, so in here when we compare, right, PL over 6, PL over 6, the same in terms of magnitude and sign. P over 2, P over 2, the same in terms of magnitude and signs. P over 4, P over 4, the same in terms of magnitude and sign. So no matter which free body diagrams, the left hand or the right hand free body diagram that you choose, you should obtain the same internal forces. Okay, and in here it's very important when we sketch our free body diagrams. Initially we assume that the internal forces are in positive sign convention. Okay, I think that's it for this lecture, and please let me know as usual if you have any questions, and thank you for listening.